Okay, so like I mentioned before, this is going to be an introduction to physics. So today we're going to be proving the equations of motion. So these are the Suvat equations, and we're also going to be able to, I'm going to give you a little bit of introduction into decomposing the vector components of the velocity of a projectile. So I just want to ask the chat quickly, is velocity a scalar or a vector quantity? Yeah, so Pentium mentions that velocity is a vector quantity. Yes, that is correct. So it has a magnitude and it also has a direction. Later on, later on we'll be able to explain this. Can you guys also see my mouse as well when I move it about? Just drop a yes. Oh, you guys can't see my mouse. Interesting. Okay. Okay, cool. Okay, so how can we derive the Suvat equations of motion? So how many of you guys have seen these equations before? If you've done additional maths, maybe you have. If not, no worries. Does it look familiar? Have you opened a textbook and have you seen these? Have you seen this before? Okay, cool. Most of you guys haven't. No worries, no worries. Okay, if you have a paper and a pen out, this might be a good time not to write these out, but I'm going to explain to you how we can derive them. Okay, cool. So you don't need to write these formula out. This is just me sort of presenting you, introducing you to physics. So in these Suvat equations, so Suvat stands for displacement, the U stands for initial velocity, the V stands for the final velocity of an object, A stands for acceleration, and T stands for time. I don't know why S stands for displacement. I would initially think that it stands for speed. It's a bit weird, but yes, S stands for displacement. So that's what we mean by Suvat equations. And these equations of motion are for when the acceleration is constant. So when a car is accelerating at a constant rate. So how do we derive it? Okay, cool. So the first thing that we got to do is we have to have a velocity time graph. Oh, okay. So in our velocity time graph, okay, cool. So now I'm just going to go ahead and bring out the the Jamboard. So can you guys see my Jamboard? Cool. Thank you so much for engaging with the chat, by the way. It makes it very easy. It makes it very easy for me to be able to understand what's going on. Okay, cool. So if I do this little laser thing, can you see? Just want to make sure you guys can see. Okay, cool. Okay, good. Okay, cool. Okay, so so this velocity is on our vertical axis, and time in seconds is on our horizontal axis. So now I have this straight line here going up. So let's just imagine that this represents a car going down a road, for example. What can you tell me about the speed of the car? Is it speeding up, and is it speeding up at a constant rate? What's going on to the car? So yeah, so Rosie Washer says accelerating. SESS, that long one says that it's increasing. So yeah. So yeah, so as you guys mentioned in chat, it is constant acceleration. So what's literally happening is that the car is accelerating at a uniform rate. And let's call, let me just take a screenshot of this. Okay, so let's take a screenshot of this. So, okay, cool. Cool. I got my next Jamboard. Okay, cool. So as mentioned, I'm going to say that S is my displacement, U is my initial velocity, V is my final velocity. Cool. So I'm now going to label parts of this diagram. So we're going to call this part the origin. So this is, let me use a better pen. So this is going to be 0. So 0 velocity, also 0 time. So this point over here, I'm going to call it T for time. And this part over here, and this top part over here. So this part that I'm going on my laser over, is it going to be the initial velocity or the final velocity? Right, initial velocity. So I'm going to label it U, label it in red. So this is my U. And then my top one is my final velocity. So I'm going to label it V. And with my V, I'm going to do little cursor thing at the top, just so that we don't get my U's and V's mixed around. Cool. So we know that it's increasing at a uniform rate, and A represents our acceleration. So we know that the way acceleration is defined. So we know that acceleration is the change of velocity divided by time taken, right? Time taken. You don't need to do anything at this moment. I would recommend drawing down the graph there. I would recommend drawing down a graph. So we can also say that because that is our definition of acceleration, we know that acceleration is going to be the final velocity, so v minus u over t, right? And you guys have seen this at GCSE, right? So this would imply, so this is what this double arrows mean. This would imply that when we rearrange the equation, we're going to go ahead and do both sides multiplied by t, time. So we're going to bring this time over here and multiply it by acceleration. So both sides multiplied by time. So therefore, we end up with acceleration multiplied by time. It's going to be equal to final velocity minus by the initial velocity. Yeah, does that make sense? Is everyone like clear in chat? If anyone's confused, just say you're confused. And this equation is going to be very important for later on. Okay, let me just bring up my. I'm just bringing out my notes right now that I did earlier last week, just to double check everything I write is correct. Cool. Okay. So this equation up here would also that goes off the Jamboard. This equation over here would also imply that v, our final velocity, is also equal to u plus by at. Cool. So this is going to be one of the crucial equations that is in the SUVAT equation board. Cool. So that's now one of the equations. So, okay. So who in the chat can tell me, because this is velocity and this is time, right? So speed is going to be equal to distance over time, right? So therefore, distance is going to be equal to speed multiplied by time. And when I say speed over here, I don't mean like the displacement, just ignore that. I'm going to change it to, I guess, v for the velocity if it makes it easier. So is this the, what is that? Okay, this is the rubber. So we're just going to call this v. So velocity is going to be equal to distance divided by the time, or the speed. So therefore the distance is going to be equal to the velocity times by the time. Now, can anyone in the chat tell me, what does the area underneath this graph represent? What does the area underneath this graph represent in a velocity time graph? Okay, I'm seeing displacement, I'm seeing distance traveled. So the area on this graph is displacement. And the reason why it's displacement and not distance is because displacement is the vector quantity of distance. Distance is just a magnitude, whilst displacement actually has a particular direction. So the area underneath a velocity time graph is going to be the displacement. Cool. So, okay, cool. So I'm just going to go ahead and bring this in. I'm just going to rub out everything that I've just done so far and take a screenshot and then bring it into the next slide. Cool. Okay. Okay. So, cool. Okay. So, right. Okay. Cool. So, let's imagine now that. Oh, that's a question. Let's imagine now that we have a trapezium. Oh, let me just get like a blank page actually. So let's imagine now that we have a trapezium. This is, oh, that's not the right thing. So let's imagine that we have a trapezium. So this is our trapezium. I'm going to go through this quite quickly because I don't want to run out of time. This is our trapezium. This is A. This is B. And this distance from the bottom to the top is our height. So it's our height. We'll call it H. So who can give me the formula of a trapezium? Yeah, I'm seeing the correct thing. So 1/2 AB plus by H. Okay, cool. So how can you use the formula of a trapezium to find the area underneath the graph? So let's just call the area underneath the graph S. And I'm also going to take another screenshot of this because I just lost it. So what is the area underneath the graph in terms of S, U, V, A, and T? Someone says rotate the graph and you can see the trapezium. That is correct. So if I just makes it a bit easier for you, this part over here, that's the top part of the trapezium. This part over here can be the bottom part of the trapezium, I suppose. And this part over here will be the height of the trapezium. If you guys are slightly confused in the chat, say you're a bit confused. Say you're not sure. Yes. So this distance over here, this is U. Right? Yeah, that's right. And this is U. That is a length of U. And then this part at the top over here, that distance is a length of V. And then this like length sideways over here is T. Right? So therefore, S, so the area of this trapezium is going to be 1/2 multiplied by U plus by V multiplied by time, right? Great. So that is like one of the first derivations for your one. That's the derivation for one of the Suvat equations. Cool. Someone asked the question in chat and asked me to clarify it. Someone said, Rosie Washer asked, if the graph was labeled speed and time, would the area be the distance because speed is scalar, or does it not work like that? If the graph was labeled speed and time, then the area would be the distance, yes. But because the vertical axis of our graph here is velocity is a scalar quantity. So our output has to be sorry, I just say velocity is a scalar. No, sorry, velocity is a vector quantity. So therefore, our output has to be a vector quantity as well. So velocity multiplied by time gives us displacement. I hope that was more clear. Cool. So that is our first equation, I guess. So you guys might want to get it down. I thought that was pretty cool. And if you go back to this slide over here, how do I view this? A view. So that equation is this one over here. The one that is like, so you guys can't see my mouse. It's like, I'm just get out of this. So that equation is this one over here. You guys see my cursor? Do you guys see my cursor? Yeah, so this one over here. Cool. That's that equation. So that's how we derive that equation. So moving on. Okay. So now I want you to try and find. So we found it now by figuring out the area of this using the formula of a trapezium. But now I want you to try and find an equation for the area by doing it like this. So imagine this red line I just drawn is a horizontal line. Find the area of this and then find the area of, and add it to the area of this at the top. Okay, so let's just label it some stuff. So what is the area of this part over here? Can you guys let me know? What is the area of this shape over here? Just drop it in chat. So someone says UT. Pentium's going a bit fast there. That's very good, Pentium. So UT, so someone said this is UT. Very good. And then can someone please give me the area of this top part over here? Someone give me the area of this top part over here. The area of this top part. 1/2 T minus T. Yeah, very good. So people are saying that it's going to be equal to 1/2. 1/2 multiplied by V minus U multiplied by T. That's very good. So now we can say that because this is true, we can say that S is equal to UT, right? Plus by 1/2 brackets V minus U, close bracket, multiplied by T, right? So that is another equation for displacement. But it looks a bit blocky because it is V minus U. So remember earlier, we found out that AT equals to V minus U. So now we're going to substitute this V minus U. We're going to substitute AT into here. So basically what we're going to do now is we're just going to plug in this value of AT into V minus U, because AT and V minus U are the same thing. Do you guys see how that works? Cool. So we're going to do S equals to UT plus by 1/2 brackets AT multiplied by T. And then this implies that S equals to UT plus by 1/2 AT squared. And that gives you your second or third equation of motion. There's no like order to the equations of motion. I'm just saying it because like there just are different equations of motions. So that is one of them. Yeah? That'd be cool. Yeah? Cool. Are we ready to move on, guys? Does that make sense? Is anyone confused in chat? Does anyone have any questions? Cool. I'm going to go ahead and just rub everything out now. So if you haven't already, I would definitely get down this equation over here. I'm now going to rub everything out. Okay. Oh, we're getting there. We're getting the person with the long S-E-S-E. We're getting there. We're getting there. Okay, cool. So that was one of the ways we could do it. So the next thing now is to do it like this. So, okay, cool. So now I want you to find an equation for S. So for this same area for all of the displacement, but this time I want you to consider this massive giant box over here, and then I want you to consider this area over here. So first of all, what is the area of this big box? Can you guys let me know? What's the area of this big box? It sounds a bit trivial to ask what it is because it's so obvious, but like I think it would help. So you know that it's VT. So it's VT. And then what's the area of this small box over here? Sorry, box triangle. So that it's going to be the same as the triangle. So it's going to be 1/2 brackets V minus U multiplied by T, right? Cool. And then because it's this big box over here, this big like rectangle, minus by this triangle, it's going to be VT minus this triangle. Is going to give us S, the area underneath this curve. Sorry, the area underneath this line. And we're going to do the same thing that we did before, where we substituted this value of AT into this these letters, this algebra, I guess. So then we end up with S equals to VT minus 1/2 multiplied by again AT times by T, which gives us S equals to VT minus 1/2 AT squared. Yeah, does that make sense? Right, does that make sense? Is everything all right, Pentium? Yeah, does it make sense? Which part is confusing you? Okay, I'm going to rub this out. Oh, sorry. Before I rub it out, the equation you want to get down is this one over here. That's the very important equation. Cool. Let me just see where we... Yeah? Okay, cool. Now, no worries, Pentium. No worries. So Pentium's talking about something else. Okay, cool. So, if anyone's confused, don't be afraid to like shout me out or anything. It's totally cool. Okay, so we get to derive one more equation now. Okay, so remember earlier we had this equation over here. We had S equals the first equation we derived. S equals to 1/2 brackets. What was it? Brackets. U plus V. Yeah, U. Oh yeah, U plus by VT. Right. This was the first equation that we had. Cool. So what we're going to do now is we're going to get rid of this T. So we're going to find a value. We're going to substitute this T. So we're going to eliminate T. That's essentially what we're doing. So elimination isn't something. So this is called like elimination of a variable, where we're trying to find a new equation, and then create. So we're going to use this equation down here that we had previously, and we're going to make T the subject of it. and you're going to see what we're going to do in a second. So this equation over here implies that t equals to v minus u over a. And then because that's true for our graph, we're going to plug this t into here, to this s. So we end up with s equals to 1/2 u plus by v, right, multiplied by, and then like big brackets, I guess. What doesn't really need brackets actually? Multiplied by v minus u all over a. Okay, cool. Now guys, does that make sense what I just done? Does that make sense? Does that substitution make sense? Can you just give me like a yes in the chat? Cool. So now what I'm going to do is I'm just going to multiply through. So I end up with, okay, so this looks a bit big. Let me just go ahead and just screenshot for this. Bring it to a new tab. Okay. No, I just lost the screenshot. Okay, I'm going to screenshot it to this new tab over here. We're actually running out of time. I need to go through this a bit faster. Okay, so now what we're going to do is we're just going to multiply through. So s equals to, I guess, just that one. So I guess we can just say u plus by v over 2 multiplied by v minus u over a. Okay, cool. So, okay, cool. So what we can then do over here is we can say we just multiply in rows like this, multiply in rows. How do I want to do this? So, okay, so I'm going to rearrange this top one over here. So before it was u plus v, but I'm going to change it to v plus u. Now, does anyone notice anything about the top? What it expands to? So anyone notice anything about the top when I multiply these two together? Yeah. Someone said the difference of 2 squares. Cool, very good. So I end up with s equals to v squared minus u squared because of the difference of 2 squares. Because I can't be asked to like fully expand it out, but that's what we end up with. And it's going to be s equals to v squared minus u squared over 2a. And then we just rearrange this. Basically to make v squared the subject. So we end up with 2as equals to v squared minus u squared. And this implies that v squared equals to u squared plus by 2as. And this is the last equation we need to know. That's the form that it usually holds. Does that make sense? Someone asked why the s is there. Oh, the s was there because of this equation initially. We derived it from this equation initially from the top. If you remember, this came from the trapezium. Yeah, does that make sense? Yeah, furious fist. Yeah. That sounds so funny to say out loud. But yeah, like it makes sense now, isn't it? Yeah, normally I would like blindly memorize it as well. That's what I had to do. But now it's like you fully understand like why everything makes sense. Yeah, Pentium in GCSE they made it X, yeah, but at A level it's S. Yeah, so I hope that makes sense. So our next role now is to have a go at a practice question. Okay, cool. Okay, so I'm gonna grab the equation. I'm gonna grab the equations of motion. I'm gonna grab this first, and we've got a question coming up. So this is our first question. In the interest of time, I'm only gonna give you guys like 5 minutes just to have a think about it, and then I'll probably go through it. I'm just gonna grab this equation. Cool. So this is our question. Can you guys see that question? Okay, cool. Okay, so this is our question. I'm not gonna read it out. Actually, let me just read it out first. So the diagram shows an arrangement to stop trains that are traveling too fast. So this train is traveling too fast, and its initial speed is 50. So it says at marker 1, the driver must apply brakes so that the train decelerates uniformly. By the way, all of these equations only work if the train decelerates uniformly, and they only work uniformly. So the train over here in the question is decelerating uniformly in order to pass the marker 2 at 10 meters per second. So I can get some information already from this question. So 10 meters per second, this is going to be my like final velocity, and our initial velocity is going to be 10 meters per second. Now the train carries a detector that notes the times when the train passed each marker, and will apply an emergency brake if the time passing marker 1 and marker 2 is less than 20 seconds. Trains coming from the left travel at a speed of 50 meters per second. So determine how far marker 1 should be placed from marker 2. Cool. So I think this question is a bit beyond you guys, but like, because I've just introduced you to this topic, of course. So let me know if you just want me to just go through it for you. So drop like a yes in chat if you just want me to just go through it with you. Just drop like a yes, or drop like a no if you want me to just like give you guys some time to have a think about it. A lot of yeses. Someone's back with paper. Can you do a bit of both, Kenty? Okay, so you want me to just like to give you a head start? Okay, cool. Let me see if I can give you a head start. Also, Tabia, I don't mind if this goes a bit over time actually. This is quite fun. So I don't mind if this goes along for like another like 20 minutes or so. Okay, cool. Okay, so the first thing I would do with this is, of course, you have all of your equations of motion. So your equations of motion are very important. So I'm going to keep them over here. You don't need to memorize them. They're already there for you in the exam. But obviously, because the more like you practice questions you do, the more familiar you will be with it. And the more easier it is for you to just like write down the equation. Okay, cool. So every time you approach a SUVAC question, it's very important to write down the like values that you're given. So you normally in every question you write down SUVAT like this. This is how you lay out your work. SUVAT like this, and you just write down like what they are equal to. So in our question, we know that our initial speed is 50 meters per second. So our u is 50 meters per second. Our final velocity must be no more than 10 meters per second. So our final velocity has to be 10 meters per second. Okay, cool. So what is this? So it then says that the marker will apply an emergency brake if the time between passing marker 1 and passing marker 2 is less than 20 seconds. So basically, if the train is going a bit too fast, really, so our time is going to be 20 seconds. And what is our job? So our job is to determine how far marker 1 should be placed from marker 2. So we don't have the acceleration, so we don't have the displacement, and we don't have the acceleration. But in this question, we don't need the acceleration. It's irrelevant to solving this question. So the equation that we use here, linking displacement, initial velocity, final velocity, and time, is going to be this one over here, our very first one. So we know that our distance, I guess, here. So S is going to be equal to our u. I like to do it like this: 1/2 u plus by our final velocity multiplied by time, and this is going to be equal to 1/2 brackets multiplied by u. So our u is our initial velocity, 50 plus by 10 multiplied by 20. Right? Sorry, that just looks a bit off. So this is our distance, basically, that the marker 1 has to be from marker 2. So let me just reword the question so that I can make sense of it. So a train carries a detector that notes the times when a train passes and will only apply an emergency brake if the time between marker 1 passing, if the time passing between marker 1 doesn't. This question really should be in a form of, the answer really should be in a form of an inequality, and it's not really phrased the best. I probably should have chosen a better question, but this is essentially how we find like our displacement. And once we plug this into the calculator, can someone plug this into the calculator for me? Oh, it is 600. Okay, 600. Okay, thank you. So 600 meters. Cool. So our answer is 600 meters. So marker 1 must be in front of marker 2 by 600 meters. Okay, cool. So do you guys get it in chat? Put like a W in the chat if you got it. like an F if you didn't get it or didn't try. Mr. Red, is that an F because you didn't try or because you don't understand? Okay, fair enough. Fair enough. Would this be 2 marks? This will probably be like 1 in an A-level exam. It's probably like 1. If they're very generous, it'll be 2. 1 for like choosing the right equation to use, and then another one for like plugging it in. But usually this would be like 1 mark. Yeah, at A-level this would be 1 mark, and at AdMaths this would be 1, but at A-level physics this would be like worth 1 mark. How many marks is each physics paper? It depends on your exam board. Okay, cool. So that's just an example of this so far. So what do you guys think about A-level physics so far? Was the derivation part quite interesting? It's very mathsy. Yeah, Rosie, it's very mathsy. At GCSE, it's like 70% knowledge and a 30% like application of like the equations. But then at A-level, it's like 70% questions with like maths in it, and then 30% like knowledge. So yeah. Someone asked, what is the difference between mechanics in A-level maths and A-level physics? So A-level physics, this is just one of the topics in A-level physics. A-level mechanics includes what I'm teaching right now. So there's crossover, crossover topics, if that makes sense. There are topics that cross over. For example, if you do maths and further maths, for me, because I covered like projectile motion really early on in further maths, like I didn't have to do any work for one of the physics topics because it just came to me very easily because I had already done tons of practice for the question in further maths, and then I don't need to do like any more questions for physics because I had already done the work in just like normal maths, normal further maths. Sorry, so I didn't need to do it for physics. Cool. So this is our next. Put it over here. So yeah, so this is our answer. Cool. So yeah, see that. So our answer is 600. So this is what we had to do. I'll ask to find distance. So our answer is 600, like this. Cool. Okay. So now our next part of the slide. I'll move on to questions in a second. I just wanted to go over this first, so we don't like lose too much time. So now, how can we decompose the vector components of the velocity of a projectile? So over here on the vertical axis, I have the vertical displacement in meters. Notice that like if I then go below the horizontal axis, my vertical displacement will be 0, and this means that I'm going like below, basically. I'm going below. So, and then my horizontal axis is the horizontal displacement. And I want you to notice that U represents my initial velocity. And so essentially what I'm saying in this diagram is that I'm saying that like this football over here is being projected into the air at some angle of theta. So theta is our angle. Does that make sense? Are you guys following this? Drop a yes in the chat if you're following this. Cool. Okay, so this is roughly what the path of our projectile would be initially. So initially we give it some velocity, give it some magnitude, some force, some initial speed, or initial velocity, I guess is more accurate. So initial velocity because it has a direction as well. It's going up at some angle above the horizontal by some angle theta. And so in physics, we do need to note some modeling assumptions about our diagram. It may also be helpful for you to note down this into your booklet for later on, so that you just get a glimpse of what this is into physics, I guess. So what are some modeling assumptions about this projectile? So when I have modeled this so far, it looks roughly symmetrical, right? So is someone able to drop in a chat, what do you assume about this diagram that I've just drawn? What do you assume in this diagram? What would be sensible to assume? So imagine you're trying to launch something into the air, you're trying to model it in your computer-aided design or whatever. Okay, so Rosie Washer says there are no external forces acting on the ball. Okay, cool. Like wind resistance, there's no energy loss due to wind resistance. It makes a lot of sense. Pentia mentions, assume that the descending velocity is the same as the ascending velocity. That's a very interesting point to bring up. It's a very interesting point to bring up. And I will speak about that more in a second. Someone says, assume there is no air resistance. Someone says zero velocity at the peak. That is very interesting. That's a very good comment to make. Yeah, so some modeling assumptions that we have are that there is no frictional resistance due to air. So all of the physics questions that you do at A level involving projectile motion will usually, and A level maths as well, but not necessarily A level further maths. But A level maths will assume that there is no frictional resistance due to air. It's also assumed that the effect due to the rotation of the Earth and the curvature of the Earth is negligible. So basically, what this means is that because the Earth is spinning, there's some really small physics effects going on with the ball, for example, because the Earth is spinning, but it's basically negligible, right? And it also assumes that the force of gravity is constant. So you know how in A level physics, the force of gravity going down is 9.81 meters per second. Yeah, meters per second squared. At GCSE, it's 10, but at A level physics, you'll work with the closer, more real value of 9.81. And yeah, so okay, so now what we're going to do is we're now going to decompose this projectile into its vector component. So I'm just going to go back into my slides so that I can explain this, into my Jamboard so I can explain this. Okay, cool. So okay, cool. So in A-level physics, right, I have a vertical displacement, and let's imagine that I label this part O, right? O for opposite, and the length of this side over here is U. This is U. The length is U. Okay, so what is O? Can someone express to me O in terms of U and the angle theta? What is O? Yes, this is trigonometry. Oh, by the way, this is a right angle triangle. This is a right angle triangle. So what is the value of O? O for opposite. So someone mentioned sine O. Sine theta. Let's be O. Someone says sine theta. So I guess sine theta equals to opposite over hypotenuse over U is opposite over U. So therefore you can say that O equals to U sine theta, right? That's not a zero, by the way, guys. That's an O for opposite. Okay, cool. So right, so we've labeled O. O is equal to U sine theta. So that is correct. And I'm going to just erase this O and replace it with just U sine theta. Yeah, so it's just going to be U sine theta. Oops. U sine theta. And as you can see, right, this is going to be a bit techie. So that's the vertical component. Can someone now give me the adjacent side? What is the adjacent side? Can someone please express to me the adjacent side in terms of theta and U by using trigonometry? Someone says cos theta times U. That is correct. So A is going to be equivalent to cos theta times U. So I'm just going to remove A because we don't really need to label it, but we can just say it's cos theta times U. So U multiplied by cos theta. It's very good. Cool. So basically, that's literally what we've done now. We've now decomposed the horizontal and vertical components of the equations of motion, right? So cool. So our our initial horizontal velocity is going to be equal to u cos theta, and our initial vertical velocity is going to be equal to u sine theta. Now the way that looks like in questions is that we will say it like this. We'll do something like this in maths. We will say something like so ux, right? Ux. So ux means the initial horizontal velocity. So this x is a subscript for oh, I don't know why this says thingy. This should be y. This should be x. How bad? It should be x. Yeah, so this x is as a subscript represents the horizontal component. So this ux is going to be equal to u sine theta. U sine theta. And then this uy So UI is the, wait, that's wrong, sorry, that's wrong. So I said UX, I meant UI at the top. So that's UI because that's our vertical. And then our UX, which is our initial horizontal component, is going to be U cos Y. U cos theta. My bad, I misspoke. So put like a heart, put a red heart in the chat if this is making sense to you. And put a black heart if you're a bit confused. It's making sense, Okay, cool. They're making sense, guys. Cool. Oh, someone's not understanding. Malicious Night, what don't you understand? What's the issue here? Also, if you don't understand because you're just here just to like have a taster, perfectly fine. Just let me know in the chat. What's the point of using trig? So basically, the whole point of this is that when we have an initial velocity, right? So u represents this like vector, as in like this like direction is u, as in like the letter u. So it's initial velocity. So what we're trying to do is we're trying to decompose its directions, right? We're trying to decompose its directions. So like what then happens is basically like if you have like u, right? So u is our initial velocity. If I then said like u is let's imagine that the ball is launched at like 12 meters per second, right? 12 meters per second. Then usually what we can then say is that it's launched at 12 meters per second. So therefore, and it is launched at 12 meters per second at an angle of like, I don't know, 30 degrees, for example, 30 degrees, right? We can then say that the initial like horizontal velocity, sorry, the initial like vertical velocity is going to be equal to u sine theta, right? So then we can then say the initial vertical velocity is equal to 12 multiplied by sine 30. Does anyone know what sine 30 is off the top of their head? I don't. Can't lie, I have to do like a diagram to figure out. 1/2? Yes. So then therefore the initial vertical velocity would be 6 meters per second. That's like why you need it in questions, yeah? Does this like then make sense? That's like the whole point of it. But I'm abstracting everything for you by like using algebra. So that's literally like the whole point of like what we're doing. I hope that opens your eyes a bit more. My bad for trying to abstract it a bit more. Perhaps it was a bit too abstract, but I hope that makes sense, right? So like imagine like in real life, we throw this ball up at like 12 meters per second and we throw it at an angle of 30 degrees. We can now calculate it's like how like what it vertically is like going up by, how far, what's its initial vertical speed. And we can then do the same thing for cos. So we can then say that, okay, so we know that it has an initial speed of 12 and it's going to be 12 times by, cos 30. Does anyone know what cos 30 is off the top of the head? Because I do not, unfortunately. I really should. This is really bad. I'm going to do the MAT soon, but yeah. Does that make sense? So it's going to be that ugly number. So it's going to be 12 multiplied by root 3 over 2. That's not too bad. Root 3 over 2. So therefore, our initial horizontal velocity is going to be equal to 6 root 3. Yeah, but in physics we would never say 6 root 3. We would actually put in the number of that, whatever this is, into a calculator and then bring it out. Yeah, does that make sense? Okay, cool. So yeah, so I hope that made sense for you guys. So that's essentially what like this is basically. Yeah, so that's essentially like decomposing the horizontal and vertical components of motion. Yeah, so that's pretty much it, man. That's pretty much it. So that is what that is basically. And now what I'm going to say is, so you know that this part over here is, let me just write it a bit smaller. So this part over here is going to be, I'm doing another color pen as well. So let's do red. So it's going to be u cos 30. That's a lie. U sine 30. U sine 30. Sorry, u sine theta. This part over here is going to be u cos theta. Okay. Okay, cool. So remember from before when we had these equations of motion over here. Right, so remember before when we had these equations of motion. I'm just gonna cover up, it's fine. we can then actually decompose these equations of motion by using this form of like SUVAT. So as in like for the vertical component, let's say for simplicity's sake, let's say that the angle is going to be 30 degrees. Let's go back to our example. Let's say the initial velocity is going to be 12 meters per second. So let's imagine a question is like, I'm not sure if would that be easy to do. So let's say, okay, so earlier we mentioned that the velocity equals to the final velocity is equal to the initial velocity plus by the actually, would that be easier? Yeah, plus by the acceleration multiplied by time, right? So a couple things to note for this question is that we've got a couple components, right? We've got a couple components. This part's going to be a bit more difficult for me to explain. So we have displacement, we have initial velocity, we have final velocity, we have acceleration, and we have time, right? And the vertical component has that as well. It's got the initial velocity, the displacement, the final velocity, the acceleration, I guess, and then the time. So let's figure out which of these is true or false. So if I launch the football some direction, like up here, for example, it's going to travel and it's going to land somewhere over here, correct? Does anyone just want to just drop like a yes in the chat? Like, yeah, it's going to land. It's going to land. Obviously, there's no feedback. Yeah, okay, cool. So it's going to land somewhere over here. So it's gone some range. It's gone some range. So we call this range in maths or physics. What we call this range. So whenever an object is thrown and it lands somewhere, we call the distance it had traveled the range. The range. So range, range. So it has a range, and we typically label this. We typically call it SX. So this displacement of the horizontal. It also has an initial horizontal velocity, and it has a final horizontal velocity as well. Obviously, when we initially give it some velocity and it lands over here, during the time of flight, so time of flight is how long the ball is in the air for. So another piece of vocabulary. So the time, that's the time of flight. It's going to land over here, and when the time of flight has been reached, it's going to have a final velocity of 0. And then what about time? So we know all of these have vector quantities, but what about time? Time is scalar, right? So there is no direction of time. This subscript represents the direction that it's traveling in. So this subscript has no direction. So our vertical component is going to be the vertical displacement, vertical initial velocity, vertical final velocity, and then the vertical acceleration, I guess. The time is the same for both. So if I give imagine if I have a bunch of equations and I have the time, for example, I would be able to find the horizontal position of it in time, how far is it, and I would also be able to find out how high up it is in time. So if I have the time, I'm able to find out either of these components, whether how high it is, how low it is to the ground, what velocity is at, what speed is at XYZ position. Cool. So about the horizontal motion. So if I'm throwing an object this way, right, and I give it some initial velocity and it has a horizontal component, right? Let's imagine that there are no forces opposing the direction of motion, and I throw it this way. Do you guys think that when the ball lands over here, it's gonna have a final horizontal velocity that is less than its initial horizontal velocity? That was quite a lot of words. Let me know if you want to rephrase. Yeah, of course. So imagine if I throw this ball like this, right, and it lands over here. Let me just draw it. Lands over here, right? If I throw it, it just lands over here. Do you think it's gonna land at the same? Do you think it's gonna land at the same speed that I threw it at? Remember, same speed, not velocity, because it's going downwards. It's going to have a different direction. But do you think it will land with the same speed or different speed? This relates to what someone said earlier, I think. Mr. Red says, I think it will land faster. Okay. Imagine, right, again, there's no There is no frictions to motion. Gravity is constant. Someone says different due to gravity. Interesting. So have a think about the energy principle. What is the conservation law of energy, guys? What's the conservation law of energy? Energy can't be created or destroyed. That's correct. So when I'm throwing it, it has a bunch of energy, right? It has a bunch of energy. And then as I'm throwing it higher and higher and higher, um, um, when I throw it initially, right, it has tons of kinetic energy, right? It can only, yeah, someone says it can only be transferred between stores. So because I throw it and it has a certain amount of energy, and then I throw it up. Let's draw another point as well on the top. So this is my like other point at the top. This is my other point, and this is my like starting point over here, right? So this is my peak. We're going to call this the peak. And there's no like wasted energy. Let's assume all the energy is conserved. Remember, no heat, no friction due to heat. It's all here. So we throw it up in the air, and at this point over here, it's gonna gain gravitational potential energy, right? But what is it gonna lose? It's gonna lose kinetic energy. So all of the kinetic energy is being transferred into gravitational potential energy. And someone mentioned that at the top, it has no vertical speed, and at this point, right, all of its kinetic energy is stored in gravitational potential energy. So actually, well, not really all, but most of its kinetic energy is stored in gravitational potential energy. So when it starts ending, when it falls down here to this point over here, remember that energy can't be created or destroyed. So at this point over here, all of the gravitational potential energy gets converted into kinetic energy, and just before it touches the ground, all of the like I guess basically virtually all of the gravitational potential energy is converted into kinetic energy, and then when it hits the bottom, it just stops and just buds, and the energy is just 100% dissipated out into the ground, right? So I mentioned before, the horizontal components stay the same, and yes, the horizontal components stay the same. There is no like it doesn't accelerate, it doesn't get slower. The horizontal component stays the same throughout its time of flight, so therefore we don't need this like acceleration. Another thing I want to note is, what do you think this acceleration, this vertical component of acceleration is? Imagine I have a ball, my football again up here. We did it in blue. Ball here. What are the forces acting on this ball? Can someone let me know what are the forces acting on this ball? Let me know in chat. Someone's gravity. Yeah, I need to drink water. I forgot how much speaking was. Okay, so gravity is pulling it down. Yes, gravity is indeed pulling it down. But just because a force is acting in one direction like this doesn't mean that the direction of motion is in the direction of the force of gravity, right? The ball is going in this direction like this, it's following this trajectory, this path, right? But there's still force acting this way. It just had an initial velocity going that way. So it's still traveling this way, but force of gravity is always acting down. Now, what's interesting is that in physics, you have to take a certain direction as positive. So I'm going to take the upward direction as positive and the downward direction as negative. So gravity being 9.81 meters per, 9.81 meters per second. Gravity is a force, and all forces have a direction. So the vertical component of gravity, this is all on Earth, by the way, it's going to be minus 9.81 meters per second squared. Meters per second squared. And this is usually all the case for most questions. Sorry, for most projectile motion questions. Cool. That was quite a lot. I think I should probably add on some extra stuff as well. So because that's true. So remember these equations over here on the right. You can express that, you can express them in this form. So for example, this question over here, you sometimes have to add like subscripts to them. Let me just remove all of this. You sometimes have to add subscripts to them. So it can look like this, for example, right? So we know that we're going to figure out the vertical, we're going to get like an equation for the vertical component, for example. So basically what I'm saying is that the vertical displacement is going to be equal to the initial vertical velocity multiplied by the time plus by acceleration due to gravity, which is we call it AY, acceleration of the vertical component, multiplied by, times by half, multiplied by t squared, right? And this is what you'll sort of learn when you come into physics. And you can also rewrite this again as like SY equals to the equals to the vertical initial velocity multiplied by time, plus by 1/2 multiplied by minus 9.81, because remember we took a positive direction to be upwards, and you end up with something like this, and then you just like simplify this down into this, basically into the vertical displacement equals to like the initial like vertical velocity times time minus 4.9 roughly multiplied by t squared, right? So this is kind of like what happens when you just do physics questions as a whole. And I'm going to walk you through a question now, and just so like you can be like aware of like what can come up, and then we'll do like a couple of questions at the end. So okay, so I'm going to grab these equations and I'm going to have a go at this question. So this question mentions that a motorcyclist is doing a stunt, and he starts initially from 1.25 meters above the ground and is landing 10 meters as shown. What speed does he take off at? So if I want to like simplify this diagram down, basically, so here's our guy, right? Here's our graph, right? Here's our graph. This is distance, and he travels a total of like 10 meters. So we know our initial like horizontal velocity is, I think we don't know actually, we're trying to figure out but we know it's literally we're trying to find out essentially what our value of u is. What is our value of ux? We're going to take this part to be 0. We know that that's distance. Okay, so we know this height over here is 1.25 meters, and we know this part over here is going to be 10 meters, right? 10 meters. One sec. And you know this part over here is sorry about that. So you know this part over here is 10 meters. Okay, cool. So this is 10 meters. Cool. So we know roughly the path will look something like this. Something like that, I guess. Okay, cool. So how would we figure this one out? Okay, cool. So I'm going to take this initial position to be my starting point. So this baseline down here. Can you guys still see my screen, by the way? Or can you guys drop like an emoji in the chat if you're still like roughly following, and drop an emoji describing to me how you feel about what I've explained so far. If you're totally lost, it's totally okay. I didn't understand it on my first like go over. Okay, some guys are feeling a bit strong about it. Some guys feel like bread. Okay. Is this like quite confusing? And also, more generally speaking, how do you guys feel about A-level physics? Is this deterring you from picking it? So it's deterring them from picking it. I'm glad this is doing the opposite effect. So do you find this interesting? This is making me not want to pick it. Okay, fine, fair enough. But yeah, I mean, physics is tough. It's tough subject. Let's get everyone online screaming that physics were. Like, physics isn't the worst. Like, it's very problem solve based. It's a very good A-level choice. So yeah, it's definitely a challenge. Oh my god, is that Jamal? Hello, Jamal. So for 5 maths, our school actually makes me pick like 3, like a lot of different options. But I plan to do like modeling algorithms, major mechanics, and then like minor stats as my options. So yeah, okay, cool. So what we're then going to do is, as mentioned before, we're going to take like this like equation over here, and we're going to say, we're trying to find out the initial vertical. We're trying to find out the initial. Okay, so let me just zoom back in the question. So our question asks, what was the speed at takeoff? Okay, cool. So we're trying to find out what ux is basically. So our ux, our initial our initial velocity, I guess. So okay, let's see what to do here. So we know that we can use this equation as well over here. So we know we can say that Vx, our final velocity, our final horizontal velocity, is going to be equal to our initial velocity, right? Plus by the gravity. Sorry, plus by. Well, there's not really any it's going to go off at the same time it comes down. Let me see. How do I do this question again? Let me see. So it goes across 10. Our range is 10. Okay, so we need to use displacement. Okay, so what we need is we're going to use that. Is that correct? Have we got even the time flight? Oh, okay. So, right. So I forgot to do this. So let me just do that. So our displacement basically is going to be 10 meters. Our initial velocity, we don't know. Our initial horizontal velocity, we don't know. Our final velocity, well, is that true? Well, it's going to be 0, right? But that's not really true. Oh, our final velocity, I guess, is just going to be ux, but we don't know what it is. And our horizontal acceleration is going to be 0, and our time of flight is something that we do not know. We do not know our time of flight. Let's try and figure out our other values. So our initial vertical displacement is going to be so imagine how would I do this on a piece of paper? So we know that our vertical displacement is going to be equal to the following equation. So it's going to be equal to our initial vertical velocity plus by our acceleration due to gravity, multiplied by 1/2 multiplied by the time squared. So because in the question it says that the motorcyclist stunt rider is moving horizontally, there is no vertical there is 0 vertical initial velocity. So this part is going to be 0. So therefore we can just eliminate that completely because it's going to be 0. So our vertical velocity is going to be equal to sy, so our displacement vertically, plus by, so we'll just 1/2, I guess, multiplied by minus 9.81, multiplied by our time. So time t, we don't know what our time of flight is, we're trying to figure it out. I think one thing that I had missed out over here was that we're taking our full point of reference, we're taking this point as a point of reference, right? So our vertical whatever velocity has to be whatever it is plus by 1.25, and it has to be plus by 1.25 because we're taking this point as our reference. So whatever answer we get is reference to this part over here, which is a bit difficult to explain. I think we can just take that in for now. So the reason why I'm adding 1.25 is because I am referring to the position of our motorcyclist with respect to this position that I have defined. That's why I have plus 1.25 there. Otherwise, if I didn't, then on my graph, I would get some other answer, but that answer will be referred to this point up here. But I want to refer to the origin, so hence why I did plus 1.25. So it's going to be, so our vertical displacement at the end is going to be whatever plus by 1.25. 1.25, cool. So we want to figure out the time of flight, I suppose. So at the end of our position, it travels 10 meters. Our displacement is going to be. Am I doing this right? It's going to be. What is it? It's going to be. Yeah. So it's going to be minus 1.25, and this is going to be equal to what is it? Minus 1/2 multiplied by. So I'm just going to do minus 4.9. So minus 4.9 multiplied by t squared plus by 1.25, right? Sorry. And we're gonna basically make t the subject and then find out what the time of flight was. So we end up with minus 2.5 equals to minus 4.29. Oops, minus 4.29 times by t squared. Okay, and then we're basically just going to solve for t. So you end up with like t squared equals to 2.5 over 4.9. Okay, and someone mentions that that's 5 over 7. So that's going to roughly be, so this is our time of flight, 2.5 divided by 4.29. Cool, but this is our value of t squared. So we end up with 0.5 roughly for t squared, and then therefore t is just going to be the square root of this. So I'm plugging this into my calculator right now. So you end up with 5 over 7. So our time of flight is roughly like 5.7, like 1 or something. So I'm going to eliminate everything above. I do appreciate, guys, your patience. It's been a bit of a while since I've done a question like this, and my confidence isn't the most highest, but I roughly know what I'm doing. Oh, okay, that's fine. Okay, cool. So I end up with my time of flight, and basically, oh, right, my range. So, yeah, so then afterwards, I just use this equation of here. So my s, so s of x, is going to be equal to my u of x plus by my v of x, right, over 2 multiplied by my time of flight. So I know my horizontal displacement is 10. My time of flight I already know, so therefore I can just say that I can just say like my range. So this is my range. This s of x is my range. So my range is going to be so it's going to be s of x divided by my time of flight because I have this 2 over here, and then I just do this multiplied by 2, and this is going to be equal to ux plus by vx. And because like these two are the same, like we mentioned before, ux is going to be equal to vx because the horizontal like velocity isn't affected by gravity. It's just going to be like 2ux, if that makes sense. And so literally what I didn't do is I didn't do 2 over like 0.71 multiplied by 2 equals to 2ux. I've got 2 on both sides, so I just cancel these out. So I just like cross these out. Let me use another color pen. Let's cross these out, and I end up with, let me rub this all out over here, and I end up with like ux equals to 10 divided by 0.71, which is going to be equal to like 10 divided by, which is going to be equal to like 14 meters per second. Okay, cool. I haven't been looking at my thing. I hope that was correct. Is that right? It was not right. It's a bit embarrassing. I can't lie. Oh my god, I'm wrong. No. Wait, what have I done wrong? Wait, what have I done wrong? Okay, one sec. They use this equation. Okay, so I'm just checking over my maths, guys. I think I've made it like I've made an error. One sec. Let me just have a look at how this works. ut, these both sides multiplied by t. They rearrange t. Then they use this. So they find out what time of flight initially was. What was my time of flight initially? I got incorrect value for time of flight. Okay, one sec. Bro, what's going on over here? Okay. Okay, wait, so I'm gonna find out so the vertical motion. Like I said, they consider the vertical motion. I'm super sorry, guys. I've actually just made an error. Oh my god, I actually just made an error. I'm so sorry. Okay, so I've got s, this, okay, this, and okay, so they're finding out time of flight. Okay, cool. Okay, so they're solving it vertically first. Okay, one second. Let me try this again. So let me try this again. I'm actually so sorry. Oh my day, that's so bad of me. Don't hire me to be a tutor, guys. I'll actually make so many mistakes. Oh my god, this is so bad. Okay, one sec. Okay, let me try this again. Wow, Tatum, you want a refund? Wow. So I pay you back the money. I'm gonna make negative profit. Wow, man. Wow. Okay, so why does it do that though? Okay, so let's have a look. Okay, so in the question, I don't know why it does it. It's really like vague there. The horizontal vertical motion. So S. Okay, so SY is equal to 1.25. And what else does it say? We know what. Yeah, we know what like A is what. So A is going to be like we don't know what U is though. So it's just 0 minus 9.81. And then we end up our U. So our like initial vertical velocity. Oh, this is such poor layout. It's going to equal to 0. Our time of flight, we don't know what time of flight is. Okay, so cool. We're just trying to find the time of flight. Someone would like an anthropology video with tiers minimum of 30 minutes. Okay, and then the equation they used was this one over here. So SY equals to like UYT plus by 1/2 AYT squared. Okay, then they said the initial vertical velocity. They just rearranged basically. So this is 0 equals to 1/2. Okay, equals to 1/2. Then just multiply both sides by 2. Over this AYT squared, which implies what? It implies our time of flight squared. It's going to be equal to what's this going to be? So 2SY over our vertical velocity. So basically saying that T is going to be equal to the square root of like 2 multiplied by 1.25 over the acceleration. But the acceleration is negative though. It's negative. Why would you do that? That doesn't make any sense. Why have you done that? Why are we taking that as positive? That's so odd. Okay, so apparently this is what they like to do in this question. It's so weird. Someone said lose the internship. No, guys, I'm fired. You know, I'm actually gonna get fired after this. You guys can't let Tatum know about this. You know, I'm gonna get fired from an internship. I'm actually gonna get fired from an internship because I messed up this question. Tatum, don't let anyone know I messed up a math question. They can't know, okay? So apparently this is the way that they want to do the question. They want to do it like this, which is super weird. And then the time of flight is apparently like 0.5, right? And then what you basically just do, as it mentioned over here, is you just plug this back into like, what is that? They plug this back into this. So Vx is going to be equal to the velocity is distance over time. So how fast does it travel? So the distance is going to be 10 meters divided by the time of flight, which is 5. And you end up with what? 20? Yeah, and the answer is 20, apparently. Which is a bit odd. But that's basically it, bro. That makes no sense. That actually makes no sense. But okay, okay, that's the answer apparently. That's the answer. The questions that I've done in the past are like they're like what? Okay, you know what? It's cool. It's cool. But basically, yeah, that's the guys. That's kind of what you can expect from A-level maths and A-level physics. So I'm so sorry. I just want to say that I'm so sorry for getting this wrong. This in physics will probably be like worth 3 marks, to be honest. This in physics will probably be worth like 3 marks. I'm super sorry again. I don't say I'm super sorry for getting that wrong. But yeah, that's A-level physics, guys. Welcome to A-level physics. So thank you, Mr. Blue. Thank you guys for your kindness. I appreciate your patience. And yeah, basically, do you guys have any questions? I'm down to do like a 5-minute or so question and answer. So yeah. Someone says, what calculator do I use? So for A-level physics, you're actually not allowed to use the CG50 graphical calculator. We found that out like towards the end. They literally told us like on like last minute, literally on the day of the exam that you guys can't use your graphical calculator. And I was like, what the flip? So I ran down to the physics office, and I borrowed a scientific one. So yeah. But for A-level maths and further maths, I recommend using the CG50 one. Simply for stats, because if you do A-level stats, if you do further maths and you do statistics, it's very useful, very useful. Someone also mentioned, how do people learn A-level physics early? I'm not sure what you mean by learning A-level physics early. Someone says, do I think you should get an iPad? So those subjects. So someone asked, right, should I get iPad for doing maths, computer science and physics? I actually chose this in the beginning of the year. I think you can still do like maths on paper. You can still do it on paper. It's totally cool. But like, I would recommend using. I mean, sure, if you want to. If your family can afford it and like, it's like money isn't the big issue for you, then yeah, sure, I'll get it. Yeah. Oh, someone asked me what are my thoughts on Questa. So guys, for personal statement material right now, I'm definitely using Questa for that. It's got a lot of resources. So yeah. Also, someone mentions apart from physics online, which other YouTubers do you use for A-level physics? Oh, that's a good question. To be honest, I haven't really looked into like A-level physics tutors too much, as in like on like the physics on like physics YouTubers side. I haven't really used YouTube like the entirety of this year. Like very little I have. Um, yeah, I just haven't. I just haven't. Yeah, I just haven't. It's mainly like my teachers that use physics. Someone also said 5/7. Is it better on it? Is it better to put your answer as a fraction or decimal? In physics, it's a bit of a weird thing when you get to the start. It's like you have to put your answer to the least significance level, to the lowest significance level that is in the question. There's no question. So yeah. So for example, if in the question, if the lowest like significant like figure is two decimal places, then you need to put it in two decimal places. But you never put it to one significant figure, if that makes sense. So yeah, basically. Um, um, someone also says you're trying to learn A levels in your first year, but you're going to college. I'm a bit stuck right now. Honestly, it's not worth trying to learn an entire A level by yourself. Honestly, like the work itself is enough. I would recommend putting your time into other areas, like learning how to edit videos, like getting good at your own subjects, doing wider reading. I mean, like going to the gym, that kind of thing. Like, like, it's much better to do all of that. No, kids, man, kids. I know I got a question wrong. Yeah, I know I got a question wrong. Don't like not pay me for it. Or my internship, bro. Okay, so Pentium asked what even is Quest.io. So that's a good question. So Questa is like this. Let me just show you guys Questa. Can you guys still see my screen? So this is Questa, basically. And Questa has like a bunch of like wider reading resources. So something that I've really been into recently is physics. So if you go scrolling over here on this left side over here, you see a bunch of these circles. And these circles are called INS, right? INS. So INN and IN. And then over here, the SpongeBob one, it's wider reading. So, and then if I scroll down, right, there's a bunch of different subjects like music, medicine, maths, material science, right, like personal statement help, philosophy, physics, for example. But I've been looking at a lot of computer science recently. So over here, if I click over here, right, what is it? Like, for example, computer science 101, you've got like P versus NP problems, right? And these are basically curated resources from people who are like actually already doing the degree that you want to study and like it has a bunch of like videos that these people have already watched for you, so you know that they're trusted because you know that they are trusted because they already like they go to like a specific place and they have they've got like a degree there, they're getting a degree there basically, so you know that you can trust these resources and these videos. Because like there's a lot of videos out there on the internet that are just really easy to access, but it may not be the most helpful, the most reliable. And then you just click on one of these videos, for example, and it pulls up this icon, and you just literally just click it. Oh, and then you can just start playing it, if that makes sense. And then let me just go to full screen mode. Yeah, so that's literally it. And oh, sorry, it's bugging. Oh, yeah. So it's not just like that. It's also got career stuff as well. It's also got like some community generated stuff. So if you want to learn more about cryptocurrency, for example, there's a list of like resources over here that you can read through. What is it? Like stuff on engineering, for example, if you're interested in that. You've got like content that you can read on like fluid dynamics, statistics versus dynamics, for example. Like statics versus dynamics, and you literally just like learn about it. And it's all resources curated by someone who is trustworthy. So yeah, basically that's what it is for now. Yeah. What's another question? Someone asked, is 4 A levels a lot of stress? So honestly, I would say that A levels is quite difficult for anyone, regardless of whether you got like all A stars or whether you got like a couple sevens, a couple nines here and there. It's very difficult. It's honestly it's so difficult. It's quite difficult. Like A levels as a whole is difficult. Doing 4 A levels is quite difficult. When you say a lot of stress, it depends on how you handle it yourself. for me, I think I can become stressed, but I'm very good at managing and regulating my emotions when it comes to like speaking to people, speaking to teachers, like knowing when you are stressed and knowing when you need to take a break in order to in order to have sustainable productivity. I think like as a whole, the whole world is becoming more like, so I think as a whole, like the productivity like area is, it's very easy to get like cooped up into the whole hustle culture 24/7, like grind 24/7. Why don't you have a business? You have time here, you have time after your 9 to 5 to like grind. But really it's like after your work day, our work is done, or after school, sometimes you feel a bit tired and you genuinely need to like relax, because it can definitely be like a lot of stress. So it depends really on like what you mean by a lot of stress. I would say yes, definitely. If you're especially if you're unable to manage your emotions and like you crack under pressure quite easily, then yeah, I would say that that's something that like you as a person would need to work on. But yeah, 4 levels can definitely be a lot of stress. And A levels as a whole is not for everyone. It's better for some people to go to technical college, for example, and learn a trade skill. So yeah. What else do I have? What's PAC studies? Pakistani studies? I'm not sure what PAC studies is. Um, for SAT or 11 plus. That's a good one. We could add SAT or 11 plus. How did you start preparing for the SAT? So Jamal, you're asking how did I prepare for the SAT? So I didn't actually prepare for the SAT. I prepared for the what was it called? I did the ACT. I prepared for it for like a good like 2 months prior, but I didn't end up doing very well. So yeah. So yeah, guys, that's all I have. I hope you guys enjoyed that A level session, and that is all really. I will see you guys, I don't know, sometime in the future maybe. Maybe I'll come up with a For You page or whatever. But I hope that was helpful, guys, and I hope you learned a lot. Maybe I hope I helped you decide whether A level physics was for you. And that's it, guys. I'll see you guys later. Bye.